Okay, so in this application we are going to implement the first simple animation. So as we know, any kind of movement what is appeared in our screen we can call animation. So in this application what I want to do is to manipulate with this red ellipse. So first what I want to make, I want to move this ellipse up according to this kind of empty circle. So basically our ellipse should go up. How to do that? In general, I don't need to modify anything, any parts related to like drawing this certain ellipse. But what do I really need to modify is the part related to manipulation with the coordinates. So the last classes we discussed that the possible to modify our coordinate by multiplying, like basically converting all of our coordinates using the special matrix operations. For example, here we set up our coordinate from the special view point. So the command set look at M will create this M view matrix. So the M projection matrix is the empty matrix. So now we are multiplying this matrix with the empty matrix, and we finally will create some other matrix, MVP matrix. In this case, this matrix will simply allocate properly our coordinate. So we discussed, like, if I will not do that, this circle is not looks like a circle, it's also the ellipse. Okay, now how can we exploit the same property in order to move this object like in any possible direction? So in general we don't need to modify anything here, so everything will be up to this circle class. See that this matrix MPV matrix, MVP matrix, is an input parameter for the function draw of the class mCircle. So if we will come to the circle, so here we can see, where is it? Okay, this is our function draw, this is our MVP matrix, which is coming inside to our application. So as we discussed before, this command will connect our MVP matrix and will finally convert all of our coordinates according to this MVP matrix. So that's why again that effect of changing coordinate will modify our coordinate. Okay, so now how to handle that stuff? As long as I want to move only this red ellipse up and the black unfulfilled circle should be keep same without any modification. So I am going to modify my coordinate here. See that in this line I am basically drawing this black circle. Here, this line, I am drawing my red ellipse. Between them, my coordinates need to be changed. Okay, so how to change this coordinate? Okay, I've already copied the necessary commands. Okay, this one. Set identity matrix. So set identity matrix is the special matrix which can hold all of the screen what we have in some certain position. So this M translate matrix, see it's red, so it's not assigned in our triangle. Actually, the way how to do it, it's also written in the renderer here. So we already have few different projection metrics. So I will just copy this matrix from here and will place it to our class here. So this projection matrix is not working in this domain, but we will simply replace the name and translate matrix here. So this matrix contains 16 numbers. So those 16 numbers is enough in order to finally modify our coordinate. Okay, now if we will come back here, see that set identity M is now working. Okay, what do we need to do next? So the next, I will need to basically modify my coordinate to some position. Okay, so how does it work? So here, like when we translate our coordinate, so this M translate, it basically will be modified right here. So how I'm going to translate? So here there are 3 coordinates available for our modification. So we do have, remember this is the 3D graphic, so the X and Y. So here will be X, here will be Y. Okay, so I am going to modify. So the third coordinate is Z, but Z will be always 0 as default for our calculation. So this X and Y will be shift according to this screen. So if I will simply set up X and Y 0, will be no any shift. But if X and Y will be different from 0, so my red circle will start moving according to this X and Y. Okay, so just in order to kind of make it clear, so let's set up as X and Y to some number. Okay, here I will simply make like float X. So just remember our circle was here. Like assume that I don't want to move from X, but Y I will move over the 0.5. Okay, so X 0, Y 0.5. Okay, so what will happen here? So now the X, Y became fine. So what do we need to do? Remember, okay, so this kind of manipulation what we did, M translate matrix, right now they did not change, they didn't modify any coordinate at all for our application. So our projection matrix in this application, in this function draw, is MPV matrix. So in order to modify our coordinate, what do we need to do is to modify our matrix MPV according to our translate matrix. Okay, and here we need some new matrix which will finally represent our coordinate. Okay, let's call it like MVP matrix, like new. So the new matrix is not exist, so but we can simply make it here. Okay, I will just copy this matrix and finally place it here. Okay, so now the MPV matrix new is available in this application. So when we finally do that multiplication, MVP matrix new, this is the multiplication of MVP matrix and M translate matrix. Okay, now again this command doesn't change anything. So we need to finally implement the modification done by this matrix to our application. So by using this line we can do it. So this new MVP matrix now will kind of change our coordinate for this application. So now let's check what will happen. So I'm just going to modify the position of my matrix M. Okay, see, it's moved from here to here. So the move was done by y. Y here is 0.5, so that's why my circle moved from here to here. This is not animation, so basically I just move my object from one place to another by using this kind of transformation matrix. So how to do it more efficiently? Because what I really need, I want to move step by step my circle from bottom to top. So it means that my y should be modified every time when I am running this code. Remember, this is the rendering. Rendering is happened 25 times in a second. So it means that this y I need to modify every time when I run this code. Okay, so what we can do here, I can write something like this. Every time when I will reach this line, I will modify my y according to some delta y. So this delta y is not identified yet, but I will just simply create this number here. So this dy is, for example, 0, 0, 1, f. Okay, so what is going on here? So I already specified my dy as some value. My y in the beginning is 0.5. So what I can do, I can like again move it to 0. So it means that my circle will start moving from the position 0, 0. Every time when I will call the function draw, so I am going to change location of my circle over the x and y. X as default 0. Y in the first position is also 0. But when I will finally reach this line, my y will be modified by value dy. So that's why in the next step, my y will become 0, 0, 1. Next step will be 0, 0, 2. So in one by one, my circle will change the location. Okay, now let's try what will happen here. Okay, that's exactly what we want. The circle will start moving from like original position up to some point. As long as like in my code there is no any limitation for this y, so once the y will reach this top button, basically it's keep going out. So once it will happen, like we will never see our circle anymore. So it's kind of completely gone. So we cannot simply do anything here. How to make it back? So remember this coordinate y is always changing this application. So it means that once it will reach the top side of our screen, I can simply move it down. How to do that? Very simple. So here I can use the if condition. If my y will become more than 1. Okay, so what do I need to do? I want to make that circle move down. So what's happened? Remember, the y is the vector, is the axis which is going up. So that's why if I will do the plus dy, so my circle will go up with the step dy. So if I want to move it down, basically my dy should become negative. So how to make the dy negative? Again, very simple, minus dy. So once that the y, our circle will reach the value 1, the center of our circle will reach the value 1, I am going to pull it down. And finally, yeah, my dy will become minus 1. Oh, sorry, the minus dy minus 0, 0, 1. So and it will go down. Okay, now let's see what will happen. Okay, so our circle is going up. Okay, the next time I am going to change the speed. So once it will reach this point, so it's going down. Okay, now the situation will be the opposite. So my circle is going down, but basically I didn't make any condition where the circle will come back. See that this minus dy will be here forever. So that's why the circle will reach this point and will simply go down. Okay, so how to avoid this part? Again, the circle will never come back. So here I can simply copy this part and say, so if my y will become less than minus 1, I am going to change my dy again. So that's why, like, when my circle moved down, my dy was negative. Once my y became less than minus 1, so the dy changed again to the positive. So that's why it will go up. So it's going slowly, so that's why I'm going to change this value. So if I will modify this number, so it means that the speed, moving speed, will be 10 times faster. So I just remove 1 0 here. So finally our circle should move much faster here. Okay, touch here, touch here. Okay, why that's happened? Because basically, like, the touching point is that point. So if you want to modify it accordingly, so what do we need to change is here. So basically here will be not minus 1, so here should be lower. Okay, what was the radius of our circle? Radius 0, 3. Okay. Okay. Okay, now that's better. Maybe 0.5. Okay, almost. So basically our circles is like touchable by that point. Okay, yeah. Now we can finally implement that part. Okay, so the same question. Can I do the same movement according to the x coordinate? Because now our circle is moving just up and down, up and down. So yes, possible to make the move vertically. So for that, I am going to create the same move, but through the x. Okay, remember the dx is not exist in our application, so that's why here I am going to make some dx. Let's make oh, 0.5. Okay, let's make it let's make it like this. So this value. So again, as long as like our circle is moving only between like the value y, so what should we do here? We also have to define the value x. Similarly, here if my x will become bigger than 1, so I'm going to create this. If my x okay. So now our circle is flying like in between the few different lines, which is like 1 minus 0.4 over the y and over the x. Like one line is 1, another line is the minus 4. So as you can see, like this circle is getting stable. It's not kind of going to be modified. Okay, so I think that's all for this lecture. So just want to show you one more thing. So I can like simply place our circle in the center like this. Okay, so it basically my circle will be just in the center. Basically it was not really much correct like to make the movement for the object which is located not in the center. So see how it will affect our application. So now the move will be from center. Okay, see, and it disappeared. So here it became 0.4. So basically like our movement stuff, like movement window moved outside. Why? Because the original position of this circle was not. Okay, so let's make that ellipse as the circle, so I will just delete that part. So in here let's make the same numbers. For example, 0.6 minus 0.6, 0.6, here minus 0.6. Okay, and let's see what's happened. Okay, so y is connected 0.6, but basically x 0.6 is much wider. Remember, our screen now is basically screwed over that part. So maybe over the x we need to make a little bit lower, like 5. Okay, so now we can see like it's getting better. Still 0.5. Yeah. Okay. So finally possible like to make like all necessary move here. Just remember all of those dx dy now is completely up to these values dx dy. We are not modifying them too much, so they are quite stable. Okay, that's all with our kind of movement, circle movement. So the next lecture will be about like movement, which is following some special law, mathematical law. So that movement will be necessary for our second homework for the graphics. Goodbye.